Hey guys, and welcome to Functional Print Friday. So last week I showed you guys this scale calibration weight set case. So inside here, if you missed that last week's video, is a calibration weight set for scales that I designed. And very happy with this with the exception of the lid. I've never been happy with how the lid came out on this guy, mainly the lettering on it. Very happy with the texture on here, but partly because of that texture and partly because it's just hard to print lettering on the underside of something. The face that goes down to the bed, you can see it really doesn't look very good. I asked you guys for some help on how I could do this better, and you guys schooled me. So let's go take a look at the comments from last week's video. All right, let's see what you guys wrote. So we'll start from the bottom. From DB, I print text on surfaces just like that without issues. Use glue stick or something similar to aid in adhesion. I also squish the material into the textured bed more than a smooth bed. Yep, definitely good thoughts. I didn't use a glue stick in the original print. I do think I had the Z height as low as I could get it to get the maximum amount of squish into the textured bed, but I haven't tried a glue stick. I might have to give that a shot. Next up, parts Dave. You could print a vinyl adhesive label over it. Also a great idea. And actually I have a dye sublimation printer that will do labels. They're small. It'll only do up to like a business card size, but realistically that's all we would need. We could have like a recess in the top of the lid to match the size of the label, so it was just below the surface. And then go ahead and just put the label after we cleared out the supports that would inevitably have to be there. The only downside I can think of is the vinyl labels, or really any label, is going to be pretty thin, and you're probably going to see the texture of the supports underneath unless there was a way to clear that up. He also goes on to say that we could do printing the letters separately in another color and then press them into the recesses. Also a good idea. Fairly labor intensive, but I think if they were, yeah, he says he suggests doing it flush. I would probably do them just below the surface to get kind of a little bit of a shadow effect there. But yeah, and he actually mentions that it's, fairly time consuming, but also not a bad idea. D. Rifak probably butchered that. Does your printer support M600 filament change? I've printed stuff with lettering on the first layer and just made the text separate. Okay, I see where he's going with this. So he's suggesting that we just print the letters first on the bed. So it'd be the first thing we printed. We'd swap the color and then we would print the rest of the layer. So once we swap to the second filament, say we did the letters in black, for example, and we swap back to the green filament would fill all around the letters and then complete that first layer. I have tried this before with limited success. The trick is getting the fill not to disturb the features, the fine features of the letters on that first layer, because when it's printing those tiny features, sometimes the adhesion just isn't that great, particularly on the textured bed. This would probably work better if we did a smooth bed. But also like the idea. From John Heeb, I'm not sure how you store the weights in their case, but I would prefer the labeling be on the sides and not the lid or base. When stacked or placed above eye level, the sides are all you see. John, thank you for completely ignoring my request of how do we fix the print on the lid of the container, because you, my friend, are 100% right. This is actually something I talk about from an engineering perspective all the time in my day job. Oftentimes we get so consumed with solving what we think is the problem, we don't take a step back and say, what's the actual problem that we're trying to solve, rather than trying to solve a problem that we're facing in implementing what we thought was the solution or what someone else said the solution was. So thank you. And thank you to everybody that commented here. And actually there's one more up here. AD said, I found that adding a draft angle when extruding lettering helps to eliminate bridging. You could fill the letters on the lid with white caulk like you did on that other thing. Also a really good idea. And actually, aside from the suggestion that we switch the text to the side of the case, that would probably be the easiest thing to try, because then we won't, if we did this, we wouldn't see what the bottom surface of those letters look like. We wouldn't see that bridging. It would just be a matter of getting the rest of those letters to stick to the bed. And again, maybe if we went to the smooth bed, we'd probably have better luck getting the small features of the letters to stick. But John Heeb, you take the cake. Thank you so much for your suggestion. I was so stuck in thinking about how I fixed the lettering on the lid, I never stopped to take a step back and say, what's the real problem I'm trying to solve? And that is having some labeling on the case. Even though I'm probably not going to forget what's in there because I don't have 10 things that look like this, I still want to have it labeled. And you're right, it's in a cabinet. and it's stacked on, it's sitting on something, and it's got something else on top of it. So reality is, I really only see the sides. So let's fire up SketchUp and see what we can do. All right, and here is what I came up with. Quite a bit different from the original design, both in aesthetic and function with the text on the side, as we talked about. I got rid of the knurling for a couple of reasons. First of all, I knew it was going to be a real pain to have raised lettering or recessed lettering with the knurling. It's just going to get lost there, and it would be a real pain to try and design around all that mesh. But I was also never really a huge fan of the knurling. It was reasonably functional, but felt pretty sharp. Didn't look great. I much prefer the look of the raised ridges like this on the print. And SketchUp makes this pretty easy to do with the copy-paste duplication tool, where you can tell it how many degrees you want to go around a circumference and how many pieces you want around that same circumference. It was a real pain to do the raised lettering on a curve. I knew that going in. I knew it was going to be a pain to do it. I ended up having to modify a lot of the mesh manually to get the text to work, just due to all of the different faces on that curved surface. But in the end, I think it's worth it. It came out looking really, really nice here in the design. Generally speaking, what looks good in SketchUp when you preview the full design looks good 3D printed. So I'm excited to see what this looks like. So let's go ahead and print. Oh, welcome aboard the struggle bus. So yeah, I've got 5 prints here that I stopped on the first layer because I could see we were having some challenges with getting the correct amount of material flowing onto that textured sheet. I don't do that much printing on the textured sheet. I do most of it on the smooth sheet. I do use the textured sheet quite a bit for TPU. So the last adjustments I made to the printer I hadn't really accounted for in my profile for PLA on that sheet, and took me 5 attempts until I was reasonably happy with the amount of flow of material. So there's a print running now. Hopefully I've got this tuned in, and we'll have the correct amount of material flowing into the base texture on that sheet. You can see this one here. This is too much material. This is what too much material looks like. You see the sort of the little mountains here? That's what happens when you're flowing too much material. And this one, yeah, this one is not enough. You can see here, this is the top surface of this. You can see they're not even really blending together, and this split super easy. This one was under extruded, at least for that sheet, and this one was over, and the rest of these are somewhere in between. This one actually might have been my last one that I stopped and was pretty satisfied with the result, and then restarted with these settings. So, all right, let's see how that goes. Nope, that one didn't work either. Looked really good at first, but then I started to see some of the same telltale signs of over extrusion. Hopefully it's picking it up, and you can see that there. And it's not, I'm not that concerned about how it's going to affect the surface finish. It will actually affect this finish a little bit, But what's going to happen is, as we then try and put another layer of material on this, there's just not physically enough room there, and it's going to make a mess before it finishes. So I'm going to adjust it again, because I think we're very close, and try again. And we're still failing. The first layer looked really good. I'm actually not sure. This is a surprise. The first layer went down really nice. We had good adhesion. I thought this was going to be good, and then as you can see, it started printing the second layer, and clearly we're still over extruding on that first layer. It might be laying down nice, but we're still putting too much material down. I think what's happening is, because of the textured bed, we're flowing it into that texture, but we're not getting a consistent top layer, and as it hits the second layer, it's just making a mess. I'm going to back way off. I'm actually going to back way off to my original settings that was significantly under extruded for layer 1 and see what that does. You know, yesterday I would have said, I think I'm pretty good at 3D printing. Today, yeah, I don't know. This is what happens when you change your process. I don't normally print PLA on the textured bed, and in fact, I have not printed PLA on a textured bed since I changed out the nozzle on my printer. So I knew that I was going to have to go through some tuning to get this to work. But I remembered I still have the original nozzle that I had taken off, and I still have the original profile that I had printed this guy with. So I thought, you know what? I'm just going to put the nozzle back on. I'm going to grab the original profile, and I'll just print it with that profile. Because I think I had only taken maybe 2 or 3 tries of just watching the first layer and stopping it early on to get the flow for this one. And other than the lettering, I'm really happy with this surface. So I did that, and you can see the mess I had here. I actually walked away from the machine. I was so convinced that that was going to work just fine, and you can see we're still significantly over extruded. And I'm like, what's going on? And I realized this texture looks a whole lot different than this one. I've got 2 textured sheets, and they're quite different. You guys probably know that if you use the textured sheets a lot. I don't. I've got 2 of them. I clearly grabbed not the same one that I printed this with, and that was leading to not only the reason why this didn't work with the same profile that this worked, but probably a lot of the overall challenge. The texture is really shallow on this, so there's not a lot of room for error. So yeah, I'm going to go back to the nozzle, the newer nozzle that I was running, and I thought I was really close before I changed course here and went back to that other profile. So let me go back to the original plan, and we'll try this again. Do you ever feel like something's just not meant to be, but you can't stop chasing it? Yeah. So this was looking really good. I had left this alone for a few hours, and if we ignore this side of it, this does look really good. Flow was great, adhesion was great, everything was looking great. Lettering was even working really nice. Loving the pattern on the outside here. But as you can see from the mess in here and sort of the double line here, this guy lifted up from the bed. You can see the line there. This part was still attached, and where this line is here, this part was lifted from the bed, and it made a big mess. I don't know if it's the textured sheet. I did clean it. It looks like it's in good shape. Maybe this material, this particular PLA, is just really hard to work with. This is Tianse, T-I-A-N-S-E, I believe. It's actually the last of this that I have. I bought this green color. I really liked it. I tried to buy more. They sent me another roll, same packaging, but the color was different. So I sent it back because it looked really similar to the Hatchbox green that I had. Just wasn't what I was looking for. I'm almost out of it. And I think the only thing I've done with that filament is actually print the original scale calibration weight case and these attempts to fix the lettering on this. And let me remind you, I mean, this whole thing is just to fix the lid on this scale calibration weight set that I think was like 12 bucks on Amazon. I don't want to think about how many hours I have spent on this, but we're going to get it. We're going to get there. So imagine my excitement when Octopi said that I had a 100% complete print. And you can see adhesion looks really good. I added a skirt all the way around the edge to fix that problem. I've done that in other prints before, and it's worked really well, and usually it breaks right off. But this doesn't look like a 100% completed print, does it? Also notice the unusual telltale pool of filament over here. If you guessed I sliced this and then uploaded the G-code before the slicer had finished writing the G-code to disk, you'd be right. This is a 100% completed print. You know, the first 5 megs of what should have been a 37 meg G-code file. So let's do it again. Ta-da! It actually finished. And it looks pretty good. Flow was great. The ridges printed really well. The top surface is super, super nice. The one problem I have is when I pulled the skirt off that I needed to keep this guy adhered to the bed, you can see there's some challenges here where the edges are just are peeling up. A little bit of delamination right at this this raised portion, and that occurs a couple different places. It's not terrible. It actually is sharp. It catches your fingers really easily. You can see that that stands up there. Otherwise, this looks really good. But I have an idea of how we might be able to clean this up, because I didn't go all this way to trade one problem for another. I want this guy to look right. So, you know what, we should probably actually make sure this works before we do anything else. Yeah, it threads on really nice. Lettering looks great. I actually really like the aesthetic of the raised surface here. We just got to fix this. All right, so we're over here at the milling machine, and if you've ever tried to do post-processing on plastic with any type of machine tool, it tends to melt. Like, you can hand sand it, but you've got to go slow even hand sanding. And if you ever try and use a power sander, it just melts, it just turns into a mess. Well, it just so happens earlier this week as a test, I had taken a failed print from an earlier video and I tried milling it. And at first, it was melting. I don't know if the light's picking it up. This section right here, it's melted and kind of got all messy. But if you look across the surface, and it is tough to get the light to hit this just right, but the finish gets progressively better going across. I messed around with the speeds and feeds with a 2-flute high-speed steel sharp end mill, and managed to get a process down that works really well. This is like extremely smooth, and this was milled just right here in this vise with this 2-flute end mill. And I was thinking, boy, this could be great for you know, surfaces that you don't get a good finish on with 3D printing, which is pretty much any surface that is not like a top surface. If your settings are tuned in, you're going to get a good finish on your top surface, but your other surfaces, you're going to have ridges on your vertical surfaces, and anything that is underneath on the bottom that is recessed, you're going to have you know, marking from the supports that you take off. So I was excited to be able to try this for a future print. But now I'm thinking, what if there was a way that we could get this guy in here at kind of an angle like this? And now imagine we have this, this flat end mill in here. This is flat across the bottom, hitting it like this, and then we turn this so that we get kind of, we cut kind of a chamfer into the edge of this. My lathe is not up and running. That might be an easier way to do this. Just chuck this into a lathe and turn this part, and then chamfer the end. Although I'm not sure about that, because the tool itself then is just going to be digging into this. It might try and pull itself in. Whereas on the milling machine, this is turning at a really slow speed. You know, but we're basically advancing the work into the tool bit that is turning at a faster speed. Not too fast. That was the trick to getting a good surface finish here, is I slowed this guy down pretty far. I think I was down about 700 RPMs, which you'd think you'd want to go a lot faster with the 2-flute end mill, and you would for, you know, steel or aluminum or other materials. But a slow feed rate, so slowly moving the material through the milling bit or the end mill, and having a fairly slow spindle speed gives you a good finish. I don't know if that's going to translate to this kind of cut, but let me see what I have that might let us position this in the milling machine to cut that face. So I've got this. This is a dividing head. This is designed to mount something in the 3-jaw chuck here, and you can turn it with this handle. And this is a dividing disc here. You can turn it to specific angles, like if you were cutting, like if you wanted to cut hex into something, or or turn a cylinder into, you know, a square at the end, or any number of faces that you needed. You could even, you know, cut gears with this if you have the right gear cutters. But this guy does actually angle, so we can flip this up vertically or at, you know, any angle we want to work more like a rotary table. Now I just checked, and I don't think that we're going to get this in this 3-jaw chuck. It's just too small. Either gripping on the inside of the lid or gripping on the outside of the base or the upper part of the lid. But I have another chuck that I actually got out of a garbage pile that I was in the process of rebuilding that is nowhere near ready to use for metal. But I think we could probably make it work for plastic. Let me grab that. All right, so here's the backing plate for this chuck, and I've never actually tried it, but I think the threads on this backing plate are the same as the threads on the dividing head for the 3-jaw chuck. So let me see if I can get that off, and if this is even going to, we'll try just a backing plate on there before I try and reassemble this guy to use it. All right, so that does fit, so in theory this should work. So let's put this chuck back together. All right, got the chuck cleaned up, in place, and everything is as centered as it can be. I put 2 layers of painter's tape under here to hopefully keep these chuck jaws from marring up the surface finish on the bottom part of our holder. And everything is centered within 10 thou. This face up here runs true within 10 thou, and this edge here runs true within 10 thou. I can't get it any less than that. I don't think it's actually out of center. I think it's just imperfections in the print itself. So there's so many different ways this could go horribly wrong, yet I can't help but try it. So let me get the tripod moved and see what happens. All right, it went surprisingly well. It's hard to see it here in the chuck, but I'm going to get this out. I think we're done milling. This is a 320 grit flexible paper. Actually, this stuff has an interesting story. I bought this at Lowe's a couple years ago. It is like a plastic backed paper. The stuff never wears out, or, well, I mean, it eventually does. I think I'm only on my second sheet of it, and I thought, boy, this stuff is great, I'm gonna buy more. I think they've discontinued it. I think they were like, oh crap, no one's ever gonna buy sandpaper ever again. We better stop selling this. If you guys have found this plastic backed 3M paper anywhere, send me a link. I'd love to buy some more of it. All right, lightly sanded that. I think that looks pretty good. Let's go get the secret weapon. All right, we're down here at my electronics bench, and if you haven't seen me use this before, this is a hot air rework station. It's meant for warming up whole chips on the surface of boards and pulling them off, but I have found that it has an even better use for cleaning up 3D prints. What I'm gonna do is let this come up to temperature And I'm going to go around. You got to be really careful not to overheat the print. But if you get it just right, you'll return that sort of as printed surface finish. You're remelting the plastic just at the surface and taking away all those light colored stress marks on the plastic. And notice how quickly I'm moving. You can't stay in any one place too long, but you can make more than one pass. Well, guys, it was quite the journey, but I think we are there. I am really happy with how this turned out from a fit and finish perspective, and thank you so much for all your suggestions on how to redo this lid. Also really happy with where we landed on the lettering on the side of this design. Like I said, it was quite the journey. We got to try out some new equipment, got to play with some new toys, and just try some new ideas. And I certainly don't consider that time wasted. And if you guys are still watching this video, you probably don't either. So if you liked this, do me a favor, hit that like button. It really helps out the channel. And if this is your first time here on my channel by chance, I do a new video like this every single Friday. So if you enjoyed this, consider hitting that subscribe button. And guys, if you do, I'll see you next Friday.